Hello, my country is under Russian attack right now. My city is safe right now, so I decided to finish this video I started the night before this full-scale Russian invasion. As you probably know, Russia struggled to make some serious military advancements, so they decided to attack mostly civilians. They are shelling and airstriking residential buildings, hospitals and other civilian infrastructure. And they're denying evacuation or humanitarian aid for seized towns and cities. People are dying without food, water and meds there. Russians are terrorizing Ukrainian citizens. Russia is a terrorist organization right now. If you want to support Ukraine, I will put some links to the government and non-government organizations in the description. I will appreciate your support. Now let's get back to our Endless Runner tutorial. In this video we will improve frontal and back obstacle positioning in our runner game to make some spacing in front and behind our obstacles. We need to avoid unnecessary cluttering of our obstacles. Be aware, there will be a lot of blueprints in this video. But first, let's look at this simple scheme. We will set some minimal margins between obstacles. And we will set some reserved spawn points where no other obstacle can be spawned under any circumstances. Also, we will convert spawn points indexes from global to local on the tile indexes and vice versa for particular purposes. Let's open floor tile actor and create SpawnObstacleBlocker and SpawnObstacleLow functions. And let's make a few changes in SpawnObstacle function. We need to set 3 info loop node to make up to 4 obstacles. And let's connect switch node to our new SpawnObstacleBlocker and SpawnObstacleLow functions. And we need to make GetAvailableSpawnPoints function with margin front and margin back integer input parameters. We need this function to get an array of spawn points where we can spawn a particular obstacle with particular parameters. These parameters define how many free spawn points should be in front and behind of our obstacle. And let's create an output integer array parameter with a name indexes. Now we need to make SpawnObstacleBlocker function to do something. Let's add GetAvailableSpawnPoints node and set some parameters. And let's set indexes array as a new local variable with the name AvailableIndexes. And we need to shuffle this array. Now let's check if there are more than 0 items in the array. If true, then we need to add child actor component with obstacle blocker parameter. We need to get the first available spawn point index, get a spawn point transform, convert it to actor's relative transform and connect it to a child actor component node. Now we need to create ReserveObstacleSpawnPoints function with index input integer parameter and margin front integer parameter. We need to use this function to save occupied by obstacle indexes and reserve spawn points in front of the obstacle where no other obstacle can be spawned. Let's add this function to SpawnObstacleBlocker and set index and margin front parameters. And let's copy all nodes from SpawnObstacleBlocker to SpawnObstacleLow and change some parameters here. Now we need to create a new struct with the name SpawnLaneStruct. And let's create an integer array variable with the name SpawnPointIndexes. Let's compose our ReserveObstacleSpawnPoints function. We need to add a sequence node first. And we need to create a local integer variable with the name currentLane and indexOnLane integer local variable. We need to convert general spawn point indexes to local indexes on a particular lane. Let's set index divided by 5 as currentLane variable. And we need to set indexOnLane variable by getting index input minus currentLane multiplied by 5. Now we need to create a new variable with the name occupied obstacle spawn lanes with the type SpawnLaneStruct array. And let's duplicate this variable and name it reserved obstacle spawn lanes. Now let's get occupied obstacle spawn lanes variable. And let's get its array item connected to the currentLane variable. And we need to break this value and set index input item as add unique item to the struct array. Now we need to add a new execution pin for the sequence and connect it to the new for loop. Let's get indexOnLane variable, add 1 and set it as first index in the loop. And let's add indexOnLane variable, add it to margin front input value and set it as last index on the loop. And let's get ReserveObstacleSpawnLanes variable. And let's get its array item connected to the current lane variable. And we need to break this value and set the loop index as add unique item to the struct array. Now we need to change construction script. Let's add a sequence node here and reconnect SpawnObstacle node to the third execution pin. And we need to get lane position variable and resize occupied obstacle spawn lanes and reserved obstacle spawn lanes arrays to the length of lane positions array. Now we need to make GetAvailableSpawnPoints function. Let's add a sequence node and make num_of_lanes local variable and set lane position length as its value. And we need to create available obstacle spawn lanes local variable with the type SpawnLaneStruct array. And let's resize it to the size of lane positions array. Let's add a for loop and set num_of_lanes -1 as its last index. And we need to add a sequence node and set loop index as current lane local variable. Now we need to add another for loop and set its last index as 4, because we have 5 spawn points on each lane. And let's add another sequence node and set loop index as current point local variable. And we need to create a new isReserved boolean local variable. Let's set its value to false here. Let's get ReserveObstacleSpawnLanes variable, get its array item connected to the current row variable, break struct value and check if this array contains current point value. If this condition is true, set isReserved variable to true. And let's rename current row variable to current lane to make it more appropriate. Now we need to create a new function CheckLaneForObstacles. We needed to check if there are obstacles on the particular lane within a particular range. Let's add lane integer input, first index integer input and last index integer input here. And let's add isOccupied boolean output parameter. We need to add a sequence node and a for loop node here. And we need to connect first and last index inputs to this loop. Now let's get occupied obstacle spawn lanes variable and get its array item connected to a lane input. Let's break an output struct and check if this array contains a loop index. Now let's create a new isOccupied output local variable and set it true if the previous condition is true. Now we need to check if first index is less than 0. And let's connect isOccupied output variable to isOccupied output value of return node. Also we need to create a new PreviousTile variable with a type BPFloorTile. Now, if first index is less than 0, let's get PreviousTile variable, check if it's valid and use CheckLaneForObstacles function from PreviousTile. We need to set current lane here, set first index connected to a plus node and last index to 4 because we have 5 points on a lane. Let's set isOccupied output true if an output is true. Now let's get back to our GetAvailableSpawnPoints function and add a new isOccupied margins boolean local variable. And let's connect it to the sequence node and set its value to false. Now we need to use CheckLaneForObstacles function, set current lane to lane, current point minus margin back to the first index and current point plus margin front to last index. And let's set isOccupied margins true if the function output is true. Let's create a branch node to the sequence node here. And we need to check if isReserved variable or isOccupied margins is true or false. If it's false, we need to get a current lane item from available obstacle spawn lanes break its value and add a unique current point to this array. Now we need to iterate through each available obstacle spawn lanes item using for each loop node. And let's connect return node to the first sequence node. Let's break array element struct and iterate through a resulting array. Also, let's create a new local variable result output with the type integer array. Let's connect it to our return node. And let's add unique item to this variable. Now we need to get an array element from the last for each loop and add it to the element from the previous loop multiplied by 5. We need this method to convert local file lane spawn point indexes to global grid spawn point indexes, and we need to connect it to our addUnique node. Now we need to create SetPreviousTile function with floor tile input parameter and its type set to BP floor tile. Let's open our runGameMode blueprint class and AddFloor function. We need to execute SetPreviousTile function from a spawned floor tile. And we need to create a new latest tile variable, set its type to BP floor tile and set its value as floor tile parameter of the function SetPreviousTile. Also, we need to set spawned floor tile as latest tile value at the end. Now we need to make our SetPreviousTile function. Let's set floor tile parameter as previous tile variable. Then we need to add a new sequence node and check if previous tile variable is valid. And let's add another sequence node here. Then we need to get occupied obstacle spawn lanes and connect it to for each loop node. Let's break its array element and iterate through each resulting array element as well. Then we need to check each element if it's bigger than 4. If that's true, that element is out of the bounds of the previous floor tile, and we need to transfer that spawn indexes to the current tile. We need to get occupied obstacle spawn lanes variable, get its element for a particular lane, break its value and get a current spawn point index -5 set as addUnique element to an array from the SpawnLaneStruct. Let's do the same for reserved obstacle spawn lanes variable. And let's connect SpawnObstacles function to the first sequence here. Then we need to remove SpawnObstacles function from construction script. Now we will spawn obstacles after we initialize and transfer data from a previous floor tile instead of construction script. Now we need to make a few fixes. First, let's open ReserveObstacleSpawnPoints function and set addUnique value from index on lane instead of a global index. Second, let's open SpawnObstacleLow function and change child actor class to BP ObstacleLow here. Third, let's open CheckLaneForObstacles function and set 5 in this plus node to make our margin range appropriate for a previous floor tile. Now we can play our game. As you can see, we have some spacing in front of each obstacle now. No frontal cluttering here. That's all for now. I hope you liked this video and it will be helpful for you. Thanks for watching.